Hey everybody, this is Larry. This is day 11 of the Leetcode Daily Challenge. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about today's problem. We have a hard problem today, so that's, well, tiring. Just a little bit of an update. I'm still trying to rush through these a little bit. My body's feeling a lot better, to be honest. I even ran a 10K today. Well, very slowly, but I'm trying to slowly recover. But my throat is not. I was doing I'm still catching up my virtual contest. I was doing the virtual contest, and even though the actual doing is fine, maybe a little bit not good, but physically I was fine. But my voice, just like my sore throat, is still not 100% recovered, and so cannot talk for that long and that much. So we'll see how long it gets before I start coughing like a maniac. So I'm going to rush for a little bit. And seems like a classic problem that I've probably done a few times. So maybe you can watch an older video instead, if this video isn't one for you. And honestly, I don't usually remember many problems, but I think this is one of the problems that I do remember because it took me a couple of times to get right. So yeah, the idea, I mean, like I said, it's probably going to be covered from the previous videos more thoroughly. But the idea that I do remember is that, okay, what is the 1D version, right? Meaning that you only have one array. Well, the 1D version is just Candane's algorithm, right? Candane's algorithm, sorry. Right? And this is something that comes up a lot. It is actually dynamic programming, believe it or not. And then for the 2D version, and I know that I'm going a little bit fast, but I'm just going to give you a little bit of a taste so you can do some research. But like I said, I probably went the more, I did this 3 different times, so I probably went the more detailed back then anyway. Yeah, so you just solve Candane's algorithm is 1D. The key thing to note is that the rows and columns are not that many, so you can actually convert this problem into, let's say R is the number of rows, C is the number of columns, right? As I define here, you could actually convert this into R choose 2 number of linear problems, right? Well, technically, if you really want to be precise, is R choose 2 plus R choose 1, right? And that, because that's the number of distinctive way to choose the beginning, the end, or to choose 2 of them, or just choose 1 of them, right? So you could convert that to all these Candane's algorithm, and then the question is how do you do that very quickly? And the idea is using prefix sum. I'm not gonna go with this part in super detail either because I'm relatively sure that I did this in a previous thing, but I will draw some visualization. And this is how I remember it. Not this one. I mean, I don't well, I guess I kind of remember for this one, but I just remember how to do prefix sum in general, right? So 1D prefix sum, of course, you have 1D, right? Okay, let's say you have an array, and you're trying to find this sub-array sum and pretend there's straight lines because apparently, I don't know, apparently my drawing skill didn't come back from the code, because it was so good before. But yeah, so prefix sum idea is just that you can represent the sub-array by with 2 subarrays, which is this one subtracting this one will leave you with this one, right? That's kind of all subset sum is. No, sorry, prefix sum setup is like. And then 2D version is kind of the same. And the fun thing is that you can actually extend this to even more dimensions if you're familiar with inclusion exclusion, right? But anyway. So so then the idea of taking a sub-array, sub-matrix, is just, well, this answer is just equal to this thing, right? Minus this thing. Let me use a different color actually. Minus this thing. Minus this thing. Right? And then now you get this. Except for we subtracted this area twice, so we have to add it back in. And with this visualization, you can, you know, come up with any, like the code, there are probably different ways to do it, off by ones, whatever, but as long as you have the visualization, they're all the same, right? And that's kind of the key idea for this. And that's all I'm going to explain for this problem, really. My throat is kind of just killing me still a little bit as I talk, and as I talk more and more especially. But hopefully with the code, it kind of makes sense, right? So here we set up the prefix sum. For the 2D one, there are actually a couple of ways to do it. I'm just trying to think which one am I more happy with. Because I do like the leading zeros, that's why. Yeah. Or like the sentinel zeros, if you will. Oh. Oh. This is off by 1, actually. Right? I always actually forget the exact setup. I mean, it's this, but then you also add the here's this, something like this. Am I going out of bounds? No, but wait, this is why would you have a string for this, for 1 and 0? Okay, fine. Okay, it's out of bounds anyway, but that's what I was thinking. But that should be right. So J is, oh no. So this is the previous row should have this. Oh, I see. I forgot that I have to add 1 for padding. Well, not padding, but for sentinel row. Okay. Yeah. I usually write this 2 different ways. So I guess I don't have a usual way of writing it if that's the case. But yeah. Okay. Right. So then now maybe you have a helper function, right? That goes you know, sub matrix of sub matrix sum maybe of from axay bxby, right? And let's just say, for the sake of, you know, thing, ax is smaller than bx, ay is smaller than by, meaning that it's going to be upper left, lower right, right? So then now, as we said, it's going to be prefix of bx plus 1, by plus 1. The thing that's a little bit tricky you have to remember is whether you want to do these bounds inclusively or not, and so forth, because I think we do want to do it inclusively. That means that I don't think we use order dimension for this one, so so I'm generalizing for no reason. Anyway, so you have this minus okay, so yeah, prefix ax by I plus 1 minus prefix bx plus 1 ay. Because ay is the last cell that does not contain ay. And we add in back in ax ay, right? So I don't know if that I use it for this one, but I you know, that's just my standard. I say standard like I do it all the time. I guess it's not that common anymore. Okay, anyway, sorry, I got distracted about that. The funny thing is that the reason why I got a little bit of loop is that I was thinking about this. Yeah, I'll tell the story another time. I can't talk today. But yeah, okay, so now that we have that set up, we just now have a lot of contains algorithm, right? For example, then now we just go for let's just call it upper, maybe, I don't know, right? And then for lower is gonna be, maybe I get arg, right? And this should be inclusive because we want the single row one. So then now we just have contains algorithm, right? So yeah, so then now we do for y in range of c. But before we do that, we have do I even need contains algorithm? It's just the longest. Well, I mean, I guess it's just the longest streak now that I think about it. I mean, yeah. I mean, for this, I think I'm solving a different problem. You can definitely use contains for this, but I guess it's just also even just simpler to just kind of count, right? So maybe I'm a little bit off base today. But yeah, so we have, or like I made it a little bit more complicated. That's okay, right? So then count is equal to 0, right? So then now you can say if some matrix sum of because now we're taking the idea is that you're taking the whole for this upper lower bound, we're taking a look at to see if everything inside this column is all ones, right? Because if it's all ones, then we can extend the rectangle and then we could get the streak going, right? So maybe I could even call it streak. So okay, so then now left right, okay, so upper we have y, lower y. If this is equal to and how many should be there if it's all ones? Well, just lower minus upper, or yeah, lower minus upper plus 1, right? So 4 is equal to lower minus minus upper plus 1. So if this is equal to 4, then we have a 1, then streak increases, else streak is equal to 0. And then now the streak, right? So best is equal to, we max it out for we even just check it only when we increase, I guess, doesn't really matter. But streak times full, right? Because that's the height of the width, and then yeah, and that's it. I guess it didn't really need contain. Well, maybe it does because I'm not doing it right. Or is that giving me the right answer? Wait, well, 0. I guess these two are trivial cases. We can't even do the first one, so that's not great. Why does the thing is 4? Even if it just looks at row 2, it is 5, right? That's interesting. Okay, so from 0 to 3, best is 1, streak is 1, and then it goes to 4. I mean, that seems fair, but why does 1, 2 not Is my sub? I mean, the only explanation is that this is wrong. Am I drawing this wrong? Sometimes I do draw this wrong. Okay, so oh. No, I think Y is right, because I use 0 based here consistently, and this is 1 base consistently. I think, maybe. But I just want to see, like, what is 2, 2, right? Because 2, 2, there's no reason why this is not all ones, or, well, 1, 2, 3, 4, 5. Did I mess something up? I mean, it's definitely this part, because that's the part that I do not feel confident at all. But okay. Still running into silly mistakes years later. My body's still not recovered though. I'm like passing out. Okay, so this is 1, 3, 4, 7, 10, which is definitely not the way to do it. Is my prefix sum weird? That might be, honestly, because I did write this in a different way today. I thought I looked at it first though. I only looked at the first row. So this is 2, okay. 3 is already, okay. This 3 is already wrong, right? Man, apparently I don't know how to do. Okay, so this math should be right, but I'm doing the prefix sum wrong today, which is sad and embarrassing. But is that not right? Okay, so you want this to be the answer of this to this. Oh, I guess I just forgot to subtract. Okay, I just didn't keep it consistent. Usually I don't write it like this, but so I use another DP, but it's harder to explain, so I don't usually do it on explain, because I don't know, it's maybe too advanced. But okay, so basic idea is right, but I guess I just forgot to kind of do the math, and not this part, And this part, the math is actually very similar to this, except for that we only do it for one new cell. So then it is for that new cell. Well, what do you get from the neighbors, right? Well, the neighbor, the one to the left, is going to be all of this, and then the neighbor to the up is going to be all of that, and then so you have to again double count the box, or you double yeah, if you add this and this, then you double count their overlap, which is just this, so you subtract that out. Pretty straightforward in theory. Yeah, and that's it. That's all I have for this one. Like I said, it's going to be R squared times C, which for this one is going to be fast enough. I guess we didn't really use contains, I lied, but you certainly can, right? It's the same idea. I mean, yeah. That's it. That's all I have for this one. Let me know what you think. Thanks for watching. Stay good. Stay healthy to your mental health. I'll see y'all later and take care. Bye-bye.